In this video, we'll do a full course on Axum, an awesome web framework for Rust. We will explore three main sections. The beginner section covers the hello world, quick dev setup, and the static routing. In the intermediate section, we will do our first post API for login. We will add cookies and REST APIs with our CRUD mock model layer. And in the advanced section, we will implement our first custom middleware, custom extractor, and implement our custom error handling and request logging. Everything is marked as the YouTube chapters below. And now, best of all, we're going to have our quick dev environment with our server terminal on the right, our quick dev client terminal on the left, and when we press refresh, we'll see our request flow on the backend and the client response with our headers, cookies, and response body. Okay, let's get coding. So first we have our Tokio main to be able to have our async. And then we're going to bring our cargo to ML. And the first thing we're going to do is we're going to add Axum. Make sure to add the latest version. And now we're going to create our first router, which is going to be our routes for hello. It's going to be the router from Axum. And then we're going to create our first route with the path hello. And then it's going to be an HTTP GET. So we're going to use the routing GET function, which is taking an async function or a closure with an async block, which is what we're doing right now. And we're going to return our HTML content, hello world. Now we make sure to import HTML, which is an Axum response type. We're going to close the import to make some space. And now we can start our server. The routes hello doesn't have all the types yet, but that is going to get solved when we're going to configure our server. Now we're going to create our address, which is just going to be a standard socket address from the standard library. And that will be from text a tuple with our IP address as an array and the port number. Then we're going to do our debug print. And then we're going to start our server. We're going to bind it with the address that we had just above. And now we're going to call serve with our router, and we're going to do into make service. So that is a way that we serve a router. And we're going to see later how we can compose routers. That is async, so we're going to do an await, and then we're going to do an unwrap. And that will be the only unwrap that we're going to do besides the mutex ones. And now we can bring our terminal, and we can do our cargo run. That will start our server. And if you open your local host on 8080 hello in a browser, you will get your hello world well formatted. Okay, so that's pretty cool. So what we have done so far is we have called route on our router, which take a path and a method router that will return a router object into our root hello variable. And then to serve this router, we are calling the into make service, which is going to take the router and make it as something that can get served by the server. Now, if you want to learn well, you need to iterate fast. And so what we don't want is to always open the browser to check what we have. So one thing that I like to do for my quick dev is I like to have the client in the cargo test. And you could also use cargo examples as well. But for now, we're going to create our quick dev in our test folder. And now if we bring our cargo to ML, in our dev dependencies, we're going to add a httpc-test. And that is actually a little library that I did to do very convenient HTTP client testing and printing of the result. So we're going to use that. And now in our quick dev, we're going to have our Tokio test to make sure that we can have our test as async. We're going to create our HTTP client with our base URL, which is going to be the local host on port 80. And we're going to do our first do get on hello. And that is async. So to execute it, we're going to do await, and then we're going to print it. And the print is async as well, so we're going to do await. So now that we have that, we're going to bring our backend terminal from the right, and we're going to do a cargo watch -quiet -clear in between each recompile. And then we're going to watch only the source folder, because that is going to be for our backend. And then we're going to execute run. So every time we're going to change a source code, it's going to recompile it and run it again. That is our server. And now on the client side, we're going to have another terminal. Usually in VS Code, I have them side by side. And we're going to do a cargo watch, quiet, clear, watch. And this time we are just going to watch the test folder. And if you use examples, you will watch the example folder, obviously. And then we are going to execute, and that will be our cargo test, quiet, only the quick dev, and then we make sure that we have no capture, such as we see the println in the console. And now when we're going to press enter, it's going to do the do get on hello, and we have our very clean response print, which is the get hello with the status, the headers, and the response body. And then later we will even see cookies. If we had set cookie, we will see the cookies over there. Okay, so that's pretty cool. Let's go back to our main.rs. And typically when you return some response, you wouldn't really do it in a closure, but you will do it in an async function, a handler function. And usually to do that, we're going to create a little handler hello section. And a handler function is just an async function that returns an implementation of into response, which is an Axum type. We're going to do our debug print, and we're going to do some alignment. Later, that is going to be very useful. And then we're just returning what we returned before. And now if we bring our terminals and we press save on the quick dev, we see that in the quick dev terminal, we have our hello request. And then in the backend terminal, we have our debug print with a handler hello. So that's pretty cool. So now, what if we wanted to pass a parameter to this URL, such as we can say hello and the name of the user? So the way it works with Axum is you will create a struct, for example, hello params. We're going to say name, and we're going to make it optional. So it's going to be an option of string. And then we're going to derive it for debug, just for us. And then the important point is to make it also derived from deserialize, from CRD. So for that, we're going to bring our cargo to ML, and we're going to include the CRD dependencies. We're also going to include CRD JSON for later. So now we can import CRD deserialize. And now in our handler hello function, we can do our params. And here's the trick, is we do a query, which is an Axum extractor. And we're going to learn more about that. And that will allow us to extract the query parameters into our function. And now it takes one type, which is going to be our hello params. So the extractor here is a tuple struct. So what we can do is destructure the params directly into our query type, such as param is just our hello params. Now we can print it in the debug if we want. And now we can extract the name out of it and default it to world if there is no name. And to do that, we're going to have params, which is our hello params type, name, which is obviously our option of string. And now we're going to do as deref. And that will give us option of reference of string. And that will allow us to do unwrap or world, a static string. So this way we don't have any new allocation. And now that we have that, we can format it this way, where we do the braces name, and obviously we put that into a format macro. Now if we press save, it's going to restart our server. And if we bring our quick dev code, and then we're going to change our doGet to be on hello question mark name equal gen. We bring our quick dev terminal, press save, and voila, we have our question mark name equal gen, and we have our hello gen. So pretty cool. And by the way, big thanks to CRUD Nebula for sponsoring this video. And also, I'm trying to go full-time on the Rust educational content. So feel free to visit my Patreon page. Any help is a big help. Okay, back to coding. So what we did here for our handler hello is that we have the argument of the function mapping to the URL query parameters. So that is what the query extractors allows us to do. But what if we wanted to have, for example, a route hello to, where the value will be in the path and not as a query parameter? So we'll do hello to Mike. So for that, we're going to build our handler, which is going to be an async function, handler hello to. It's going to return the implementation of into response. And then as a function argument, we're going to have our name. And now we're going to use a path extractor from Axum. And we're going to give the type. And then we're going to see how we map that above in our router. And path is a tuple struct as well, so we can destructure it directly in the function argument. So now that we have that, we can just paste very similar code than above, but now with a name variable. Now if we scroll back up, we are going to do in our router, we can add another route, which is going to be route hello to. And the trick here is we're going to do a slash, and then colon and name. And so that is what tells Axum where to extract the data from for the path. And the mapping is by order, it's not by name. And then we're going to give our get handler hello2. And that's it. Now we can bring our quick dev code and terminal, and we're going to change hello to hello2 mic. We're going to press save, and that's it. We have a hello2 mic with our strong mic over there. So that is pretty cool. So now we're ready to build our static routing. But before that, we're going to use a cool feature of Axum, which is composition of routers. And for that, let's rename our section routes hello. And we're going to have a function, very simple function, which is going to be routes hello, which will return the router. We're going to copy paste what we had above. And now on top, we're going to do our router new, but dot merge the routes hello. And that is allowing us to compose multiple routers together. And now our routes hello is not really routes hello anymore, but it's going to be routes all, because we will compose different routers into this one. And we have everything much more componentized now. Okay, so now let's implement our static routing. So it's going to be route static. That will be the naming convention we're going to follow. And we'll return the router. We create our new router. And now, because it's a static file routing, we want to have a nested path. So we're going to call nest service, which is going to allow us to give the root of the URL that we want to take it from. So we're going to map it to the root of the domain name. And then we're going to use a pre-built service to serve the directory. And that is going to be a get service from Axum. And the service to do that will be a serve dir, and you give the local path. Now, Axum is very well componentized, so serve dir is not part of the Axum core library, but Axum uses Tower as a service library. So the way it works is, if we bring our cargo to ML, we're going to import tower.http, and we're making sure to import the features fs for file system. So once we have that, then we can import the tower HTTP serve dir. And so that is one of the things very well done in Axum, is rather to have his own service infrastructure, APIs. He uses towers to do these kind of things, and then you can piggyback on the tower ecosystem. So now we're going to go back to our route all, and rather to merge it, because Axum makes sure that we cannot have overlap of URL. And so since we're nesting from slash, that will overlap with our hello. But usually, static routing, you will do it as a fallback. So what we can do is fallback service, and we give our routes static. And so if it doesn't find it in the route above in all of the merges, then it will go to the fallback service. So now if we go to our quick dev, we're going to do a do get on source/main.rs. Obviously, you will point that to a web folder somewhere, but for now that will do it. Then we do our await, print and await. And now if you press save, we get our hello2 mic. Then if we scroll down, we get our source main with the content and even the right content type, which has been set by our serve dir. So that is pretty neat. So let's delete that. We're not going to use that so much. And now we're ready to do our first login API. And for this, the first thing that we're going to do is create our error module for when the login fails. So we create our module. So we get into our module, and then we're going to do a pub enum error. And so for this example code here, everything will be in this error. Eventually, you might want to split it in different layers. And for now, we're just going to have our login fail error. We're going to make it debug. And the best practice that I like to do is to export a type alias of result on top of this error type. And then I will re-export result and error in the parent module, such as I always have a pair of matching of error and result. So that allows me to normalize everything pretty neatly. But obviously, this is just a personal preference, so do what works for you. Now, the important things from an Axum standpoint is that we need to implement into response, which is a trait of Axum, for error. And that is really a key trait in Axum. And then the only method that needs to be implemented is going to be into response. It's going to consume self, and it's going to return a response, which is an Axum type. And that is going to become very critical later. But for now, we're just going to do a debug print, and then we're going to return a temporary error for now, which is going to be internal server, and then we're going to say unhandled client error. And Axum has from this tuple into response. We're going to make that much more advanced later, but the key here, which is very important from the start, is to never ever pass through your server error to the client, because that is a big security exposure that you don't have to take. So in security, it's very important to have the lazy path being the safe path. So by default, if we don't put extra work, we don't send extra information to the client. Later, we're going to see how we can have best of both worlds, where the server will have all the information and we can cherry pick what we want to send to the client. But for now, this simple solution will work very well. Now, if we go back to our main.rs, I'm going to re-export, and that is just my best practice for now, from this module error, the error and the result. So like this, I have create error and create result that I can import in other modules. And if some modules have their own error and result, they will follow the same pattern. Again, this is just a personal preference. And now we are ready to do our login API. And for that, we're going to start being a little bit organized, and we're going to add it into a web layer. And eventually you want to move the other routes into the web layer as well. So we're going to create it, and we're going to create it as a folder because we're going to have some modules. Now inside our web module, mod.rs, we're going to create another submodule, which is going to be for our routes login. So now we can jump into it. So far we have created this structure, which is we have our error for the crate. Eventually you might have errors for the main submodules. And then we have our web modules and submodules that will grow over time. So first we're going to use our create error and result. And then we're going to define the payload of the login, what will be sent from the client. So we're going to say login payload, and that will be the username and the password. And both will be strings. That will be debug just for us. And it has to be deserialized from CRUD because it has to be deserialized from JSON to Rust. And now we're going to implement our login handler, and that's going to be an async function, API login, and we have our payload. And now we're going to use the extractor JSON, which is a body extractor. So you can have only one body extractor per route, and it has to be the last argument. And now the type is going to be our login payload that we just defined below. And now you can return a result of JSON of value from CRUD JSON. So we're going to make it simple for now. And the reason why we can use our result is because the error implements into response. So everything has been wired. Now we're going to do our debug print, and eventually you are going to have to implement a real database authentication logic. But for now, we're going to hardcode it. So it's going to be payload, the username is going to be demo1, and then the password is going to be welcome. And if not, we're going to return early with the error that we created, login fail. So far so good. Later, as part of the login, we're going to create our cookies, such as the cookie can be sent to the client, such as the client can keep the session. And now we're going to create a success body. And that is going to be very simple for now. It's just going to be a JSON from CRUD, and we're just going to have result success equal true. And now as a return, we're going to have OK body. And then that's it. And that is our API login handler for now. And the best practice right now is a routes underscore something will have a function, a public function, which is going to be routes, which will return the router of the whole module. So that will be the convention that we're going to follow. Obviously, you can have your own. Now we're going to have our router new, and we're going to route API login, and that is a post. So it's a routing post, and we're going to give our login handler. We make sure to import router. And now if we go back to our main.rs, we're going to merge. So that is we're just going to compose normally our web, routes login, and routes. We're going to press save. We go to our quick dev. We're going to split into two statements. So we're going to have our request login. We're going to do a do post on API login. And then as a JSON, we're going to have our username, demo1, password, welcome. And now as a second statement, we're going to execute it. So we're going to do the .await and the print .await. And now if we bring our quick dev terminal, press save, we get our hello to Mike. And then if we scroll down, we get our API login with our result success. So that is pretty good. Doesn't do much right now, but at least we have it working. And if we bring the backend terminal, we can see that our handler for Hello to Mac was called, and the handler for API login was called as well. So everything adds up. So now if in our quick dev, we're going to add the wrong password, press save, and in our terminal, we get our internal server error with our unhandled client error. And if we go to our server terminal, we get our API login with the login fail. So we have all the information on the server, and right now we have close to nothing on the client, which is what we want to start with. Okay, so let's get back to our working state. And now as a next step, we can create our first layer, and we're going to create a special layer. So it's going to be an async function, and it's going to be our main response mapper. And that is a special layer in Axum that takes a response, which comes back from the router, and now it will return a response, which can be the same because we are consuming it, or can be a different one. So right now we're just going to return the same, and we're just going to do a debug print, and then we're going to print an empty line. And that will allow us to have an empty line in between each request, such as we can see better the request flow. And later, we're going to see how this main response mapper is going to become critical in how we're going to handle our server and our client error. So now the way that you add a layer or a middleware into a router is with the method layer. You use a middleware module, and we're going to use a special middleware, which is going to be the map response. And we're giving our main response mapper function. So now if you go to your quick dev and you press save on your backend terminal, we're going to have this little empty line because that is what we added at the end. And we can print save again, and we see again the spaces. Okay, so now it's time to add cookies to our login. And for that, we're going to bring our cargo to ML, and we're going to add Tower's cookie. So again, most of the middlewares are part of the Tower ecosystem. And now we can add our cookie manager layer from the Tower cookies, and we're going to call new. Now, one very important point to understand is that the layer gets executed from bottom to top, meaning that if you want to have the cookie layer data in other layers, other middlewares, they have to be on top. So that is very important to understand. We're going to see how it works later. So now we can go to our routes login for our API login handler, and we can add an argument, which is cookies, which is of type cookies from our Tower cookies. And that has an extractor implemented for it, which now allows us to call the cookies to add a new cookie. So for example, here we're going to add a cookie, Auth-Token, and we're going to hardcode a format right now, which is user dash the user ID, the expiration date of the token, and the signature. So that is just an example of a format for now. Now what we're going to do is we're going to take the Auth-Token and we're going to actually make it a constant on the parent module, because that will be reused in other parts of the system. So we're going to take the Auth-Token, we're going to put it there, and we import the web module. So eventually, you want to implement a real authentication token generation and signature. But that is not the topic of this video. But this is a place to do it. Now, if we bring our quick dev and our quick dev terminal, and we are pressing save, if we scroll down to login, we can see that we have a set cookies, and we have the cookie values that we just set. And we have our response cookie, because the HTTP response now has a cookie as part of it. And then the HTTP client has also a client store, so that is part of the HTTPC client library. And so we can see here the client cookies, which is our Auth-Token. And in fact, if we were going to take our Hello to Mac on top and duplicate it after the login and press save, we see that our first Hello to Mac doesn't have any cookie. If we scroll down to login, we see that the cookie has been set. We have it in the response and the client cookies. And now if we scroll down to the second Hello to Mac, we can see that it has the client cookies. So that is pretty cool. Okay, let's remove our second Hello to Mac. We don't need it. And now that we have that, we are ready to implement our REST API. And for that, the first things we are going to implement is a model layer. So we're going to have a model module. We're going to jump into it. And so the architecture that I like is this one where you have the web event, context, and model and store. And today we're going to focus on the web layer, which is our REST, our handlers, middleware, and so on. the context, which we are going to have a quick introduction later, and the model, which is what we're going to implement right now as a mock model. So the implementation here is going to be a simplistic model layer and with a mock store layer embedded. You don't want to use it for production, but the goal is to have the model interface relatively close to where you want to land later, such as then you just have to change the store layer and the model layer implementation, but the rest doesn't really have to change too much. So first, we're going to use our create error and result. Eventually, you probably want to have a model error and model result pair here. We're going to use CRUD, and because it's going to be extremely simple and in-memory store, we're just going to use the standard arc and mutex. So in our first code section, we're going to have our ticket types. So that is the item that we're going to have the CRUD on. Like a ticket is like a to-do, like a task. And the first one is going to be the ticket that are going to be saved. And that is just going to have an ID, which is a U64, and a title, which is going to be a string. And then we're going to have it clone because we need to store it, but we need to clone it such as we can send a copy back to the client. And then we're going to have our debug and our serialize because it has to be serialized to JSON when we want to send it to the client. Let's make some room. And now the second type that we're going to create is a struct for ticket for create. So that is the payload that is sent for the create API. And for now, the only thing that the user can create is a title, because obviously the ID is generated by the backend and not by the client. So on this one, we're going to derive it from deserialize, because the only thing we need is to deserialize from JSON to Rust. So now that we have these two types, and eventually you might want to have a ticket for update, which might have a lot of option properties, such as it can be a partial update. But for now, we're just going to do the create, the list, and the delete, so that will be plenty enough. Now we can close this section. So one pattern that I like to follow is to have the model controller. And for now, it's going to be extremely simple. It's going to be a model controller, and it's going to have the store embedded in it. And usually, it will be more kind of a database connection or SQLX inside the model controller. But right now, the store is going to be embedded in it, and it's going to be in memory. So it's going to be tickets store. It's going to be an arc, and we're going to put everything behind a mutex, and it's going to be a vector, so that will be our store, and that will be an option of ticket. But for our mock, we're going to use a vector ID as a sequential number, such as is going to be our ticket ID. And so we put it option, such as when we're going to delete, we're just going to swap the option by none. So obviously that doesn't work in production because that will be a vector in memory that will grow infinitely. But for our mock store, it's very simple and it's behind the interface anyway. So now we're going to derive it. We derive it from clone. So that is important because that will be an application state. And it's important to note here that the clone doesn't clone the vector, obviously. It just clones the arc. And then we have a mutex that protects our vector, that makes the access of our vector exclusive. Now we are ready to implement our constructor. And it's just going to be a simple async new function that will return a result of self. And in the return of self, we just need to have a ticket store and the arc and the default. Now, because we use the arc default here, we could also derive directly on the model controller, such as we wouldn't have to implement a constructor. But in fact, what you want is to control the signature of the constructor early on, such as then after you can swap the implementation with a real use case. So by making it async and returning a result, we are now sure that we can cover all of the cases and not paint ourselves into a corner. And now we can create our CRUD implementation. And one best practice that I like to have is to have different blocks of implementation per type of methods. But obviously you can put everything in the same block. This is just a personal preference. So the first CRUD method that we are going to implement is going to be our create, which is going to be an async create ticket. We'll take a reference of self and then our ticket for create, and it will return a result of ticket. So the ticket that has been created. We're going to get the store as a mutable from our ticket store. We're going to lock, and we're going to unwrap. So that is for the mutex. And now the ID, and that is why it's a little bit hacky, but it kind of works, will be the store and the length, which is basically the index plus 1. And it works because, again, Rust guarantees that we have exclusive access to the store array, read or write, with the mutex. Now we can do a ticket, the ID, and the title will be our ticket for create title. And eventually here you can check if it's empty and then return a result if the title is empty or something like that. And now we're going to push it into the store. We don't forget to push it as an option, because when we are going to delete it, we're just going to take it out and leave a none over there. We're going to do a ticket clone, and then the original one, we're going to return it as a OK ticket. And that's it. We have our create. Now, if we look at our list tickets, it's going to be relatively similar. So it's going to return a vector of ticket. We're going to get our store. We don't need mute anymore, so we can remove it. In this case, it doesn't really matter because the lock is exclusive anyway, but it's always good to have the intent correct. And then we're going to have our tickets, which is going to be our store. We're going to iter, and then we're going to do a filter map, and we're going to clone our tickets, which is going to clone the options. And because this filter map is going to exclude everything which is known. So everything that has been deleted won't be returned. And now we're going to collect. And now we're going to implement the delete. And eventually you want to implement also the get and the update. But for this tutorial, that will be enough. So we're going to do the self, and then the ID is 64. And then it will return a result of the ticket that has been deleted. So it will return an error if the ticket wasn't found, obviously. So we're going to get our mute store. So in this case, we need to have it mutable, obviously. We're going to get the ticket that has been deleted, which is going to be our store, get mute with the ID. And now we're going to do and then, so if it's found, which is going to be the option, we're going to take the value out. And so that will return an option of ticket if it was found. And so now what we want is to return an error if it wasn't found. So if we bring back our error.rs, in our error enum, we're going to add a section for our model errors. And eventually those, you will probably want to refactor them into the model layer, obviously. But right now we're going to put them there. And it's going to be ticket delete, fair ID not found. And we're going to have that as a struct variant, such as we can name the property ID. So now that we have that, we're going to return a ticket. We're going to make it a result with OKR. And if it's none, we're going to return our new error, which is ticket delete, fair ID not found, and the IDs that were given to us. And that is the beginning of our mock model layer. So now we are ready to go to our web layer, and we're going to add a submodule, which is going to be our routes tickets. We're going to create the module, and we're going to go to the file. Now we're going to use the model controller and the ticket types that we created, and we're going to create our REST handlers. And since we have done the heavy lifting in the model layer, it's going to be actually very simple. So we're going to have our async, create ticket, we'll return a result of JSON of our ticket. And here's a trick. You will take the model controller as a state. And we're going to see how we're going to wire the state later, but this is the application state here that will be created and shared across all of the handlers. And the state is an extractor, a little bit like the other extractor, but at the application level. We're going to have the ticket for create, which is going to be our JSON body extractor of the type ticket for create. So the state type is an extractor for state and is actually a tuple struct. So now we can destructure it directly in the function arguments, and the same thing for the JSON body. And now we're going to have our debug print, and we're going to have our let ticket. We're going to call our model controller, create ticket. We're going to give our ticket for create a wait, and now all the hard work has been done, and so we can just return JSON of ticket. We can do the same thing for the list. So the list will return a result of JSON of vector of ticket. We'll have the same state. At this point, we're not going to have any argument for filter or includes in the list ticket. That will be the subject of another video, but obviously you can have more information and query parameters over there. We're going to have our debug print, and now we just list our tickets and we just return the tickets. Because again, most of the hard work has been done in the model layer. And then we're going to do the same thing on the delete, which is going to return our JSON ticket. It's going to take the model controller as a state, and then now it's going to take the ID in the path to respect the REST API. We're doing our debug print, we're calling our delete tickets, and then we return our JSON ticket. We make sure to include the path extractor, and now we're going to create our router. So it's going to be routes, and now the routers need to pass a state. So for that, the routes will take our model controller as an argument, and then we'll return the router. We create our router, and then we have our first route, which is going to be on tickets. And in fact, on tickets, we have two handlers. One is going to be the post to create it. So that will be our create ticket. And then we can chain it with the get for the list tickets. And then we have another route, which is for the tickets / the ID. And that is by order. It's not by name again. And then we're going to have the delete ticket. And if you had a get ticket and an update ticket, you would chain them here because they will have the same route URI. And now here's a trick to make sure that all of these handlers can get the states. We do a with state and we give our MC. And then that's it. If you press save, everything will compile nicely. So now you can pass one state. But actually, Axum has a very nice way to be able to pass multiple states. We're not going to use it, but I'm just going to show it here. So you can have a struct and you have app state. And here we're going to have our substates, which is going to be our model controller here. And you can have as many substates as you want. So here we're just going to do with one, but you could have other ones, like a Redis connector or S3 or whatever you want to have. And now you are going to derive it from clone and then from ref. And from ref is a trait, but is also a macro. So you can implement it by yourself, or if you use a macro like that, then we need to bring our cargo to ML. And now we need to add the version and the feature macro. So that is a trick. So once you have that, you are going to have the from ref macro, which will make every sub-properties a substate that you can inject. If we go to the route, and we're going to create our app state with MC, and now we take the app state. Now we go our with state, which obviously cannot use MC anymore, but we're going to do app state. And now that we have done that, everything works as before. So all of the bindings that we have done in our REST handler, like state MC, still work as before because MC becomes a substate. But your handlers and all of your middleware doesn't have to know if it's a main state or a substate. So that is extremely powerful. We're not going to use it for now, so we're just going to delete that and go back to our with state MC. Okay, so now we can go back to our main.rs. And the first thing that we're going to do is we're going to have main returning a result of void. That will make things more convenient when we're going to initialize our model controller. And now we're going to initialize the model controller. And for that, we're going to have model controller, new, await, and question mark. Now that we have that, we can merge our REST API. So we could call merge, but we can also merge it with a nest function, which will merge all of the routes under /API. So all of the routes didn't have API, so that allows us to prefix everybody with /API. But the routes wouldn't know that they are nested below the /API. So that is actually pretty nice, again, from a composition standpoint. And now we're going to have web, routes tickets, routes, and then obviously we're going to give our model controller and we're going to clone. Here we don't really need to clone it because we use it only once, so we could just pass it. But we're going to do that because later we're going to use it multiple times. Now if we bring our quick dev and we're scrolling down, we can add our create ticket, and that would be a post, API tickets, and we're going to create our JSON, ticket AAA. And then we're going to execute it and print it. And then we're going to do the list as well as a one-liner. So we're going to do a do get on API tickets, await, and print. If we bring our quick dev terminal, press save, we have our hello to Mike. We have our logging with our cookies. And then we have our post on the API tickets to create, which return the ticket we created. And then we have our get on API tickets to list what has been created. If we press save again, we're going to have two items that has been created. Now, if we go back to our quick dev and we're going to do a do delete on the API's tickets ID1, and we're going to await and print it, we're going to press save. And now we see that the list has two, but the one has been deleted. And if we go back up, we can see that our delete on API ticket 1 has deleted the ticket of ID1. Now, if we were going to press save again, then we'll get our unhandled client error. Obviously, because it fails because the ticket wasn't there. Now, if we go to the server terminal, we're going to see that for these handlers, the delete ticket, we have all of the information on the server side. So that, again, is what we wanted. We have a little alignment bug here. We'll fix that later. So let's delete the delete because we're not going to use it much anymore. So now, if we were going to comment out the request login, so we don't do login anymore, and we press save, what we realize that our create tickets still work and our list tickets still work. So we don't want that because what we want is to require the user to be logged in to be able to get data or save data. So let's implement that. And the way we're going to implement that is by implementing our first custom middleware. So let's go to our web module. So let's create a submodule for Auth middleware, and we're going to name it MW for middleware _ auth. So that is going to be the module where we're going to put everything that relates to authentication. So let's jump into it. We are going to use our Auth-Token and our error and result. And now the simple way of implementing a middleware is to implement an async function, and we're going to prefix it with MW. And this one will be a require auth. So it will be a middleware that will require the authentication, and at the beginning it will just check the cookie existence. And the way you do that is you need to parameterize with B for the body, and then you are going to return a result of response. And the boilerplate code, you have two arguments at least, which is a request over B and next over B. And then as a return of the middleware, you are going to return OK, next, run, request await. So it's a little bit of a mouthful, but it's relatively simple, and then it gives you a lot of power because that allows you to be in between the request flow. And the beauty about the middleware is that we have the whole power of the extractor model. So now in the middleware, like we had before, we can use cookies from our tower cookies, and that will be the extractor that will give us the cookies. So then after we can just do our Auth-Token equal cookies, get our Auth-Token cookie, and then we're going to map it just to return the toString. So eventually you are going to want to do real Auth-Token parsing and validation. We'll do the parsing later. The validation will be the subject of another video. But for now, what we're going to do is we're going to take this option and return an error if the Auth-Token was not there. So let's get our error file, and we're going to have another section, which is going to be our auth errors, and we're going to do auth fail, no Auth-Token cookie. So again, the reason why I have this section here in the create error is that eventually those sections might become submodule errors. But everything is kind of organized from the start. And so now I'm going to do an OK error with the error we just created. And we do the question mark, such as we return early. So if everything is fine, it will do the OK next return. Otherwise, it will return the error. Now, if we go back to our main, we're going to do a little bit of refactoring. We're going to have our routes API, which is going to be the route that we have over there. We're going to put route APIs over there. And now, on the routes ticket, we're going to add a route layer, which is going to be our middleware from FN. So you could also implement a struct to do your middleware, but the simplest way and very powerful way is to use the from FN like that. And now we're just going to give our middleware authentication, middleware require auth. Now, the reason why we have the route layer and not just layer is because we want this middleware to be only applicable to this router. So the route hello and the route login won't be impacted by this middleware. So that is a way to ensure that this layer is only for this one. And it will only apply to the routes API. Now, if we bring our quick dev and our quick dev terminal, and we have our login not activated, we're going to press save. And now, if we scroll down, we see that our post on API tickets fail, as well as our list tickets. And if we bring our server terminal, we're going to see that the first request works fine, but the next one failed with a no Auth-Token cookie. And the same thing for the list. And now, if we activate our login, we're going to press save. Now, hello to Mac works. We scroll down. Our API login was a success, set the client cookies. And if we scroll down now, we have our post on API tickets that has a Auth-Token cookie and therefore has been a success. And we have the same thing with our get that has a cookie and that returns a successful response. And obviously, if we press it twice, we get 2 tickets. And if we bring our server terminal, we see that we had the errors before, but then everything was fine. So that's pretty cool. So now let's go back to our middleware authentication module. And so the first thing here that we forgot is we forgot to put our debug print. So we're going to put it there. And that is going to be nice because if you press save on your quick dev, and you are going to see that the require auth has been called on create tickets and list tickets, and not on the hello2 and the API login. So everything has been working pretty nicely. Okay, so now let's do some token parsing. So we're going to parse the token of format user-user ID dot expiration of the token, not of the cookie, and then the signature. And that will return the tuple of user ID, expiration, and signature. The expiration and the signature is not really the scope of this tutorial, but we're going to parse them as string anyway. So we're going to create our parse token. Could take a reference, but right now we're going to take the ownership. And then it will return a result of the tuple that we have above. Now, one thing that we're going to use is regex, and actually we're going to use a little library on top of the official regex, which is lazy regex. And that allows us to lazy compile a regex once and reuse it many times. And it's also had a pretty cool macro that we're going to see right now. And then we're also going to do some prep here in our error.rs. We're going to add a auth token wrong format. So that would be the error that we're going to use. So we're going to use a regex capture from our lazy regex. And the way that the regex capture macro works is that it takes a string literal as a regex, and that will compile it once, take a reference of our token, and then it will return a tuple with the whole token, and then next, the tuple member will match the regex group below. That is actually pretty cool. And everything is reference of string, obviously, and it will return an option of this tuple. And so then after we do a OKR with our error we just created. So now what we can do is we can parse the user ID from a reference of str to a U64, and we're going to map the error to the same error that we have above. And we do a question mark. And so now at the bottom, we're ready to return the tuple with our user ID as a U64 and the rest as strings. So now if we go to our require auth middleware, we can update the code to parse the token, and that will be our tuple. So first we try to get it from the option, and then if that works, we're going to pipe it into our parse token. And then we do a question mark to make sure we return early if any of those fail. And eventually, and that is not the scope of this video, we will need to do some token component validation to make sure that the user ID, the expiration, and the signature all match. And that in many ways is not really dependent on any specific framework, and we'll have a specific video for that. So now if we bring our routes login from our server, and we're going to change the formatting of our token, so we're going to break it, and we're going to bring our backend terminal, and then you press save on your quick dev file, and now we're going to get this auth token wrong format from our require auth middleware. And we get it 2 times, but the 2 first requests works perfectly fine because they didn't have this middleware. And now if we fix it, we press save, the server is restarting, you press save on the quick dev, and now everything is working nicely. Okay, so that is pretty good already. Now, one of the issues here is that the user ID is a little bit lost here in the middleware. Because let's bring, for example, the routes ticket. It will be nice that in the create ticket handler, we get the user ID, such as when we create the ticket, we can give the user ID such as we have who created the ticket. And in fact, you will probably also want it to have in the list and delete ticket to check if the user have access or not to it. So the way to do that is with extractors. So we have seen how to use default extractors like query, path, and JSON, and external extractors like the cookies one. But now we're going to see how to create our own extractor. And in fact, we don't only want to have an extractor for user ID, we're going to make it a little bit more general and have it the concept of context. So we're going to go back to our main, and we're going to create a module CTX for context. So like this, it doesn't conflict too much with other context. So the important point here is that the context is at the root, because it will be used by the web layer as well as the model layer. So our context is going to be very simple for now. It's going to be just a struct, which is going to be a context, and it's just going to have the user ID, u64. And it's just going to implement clone, because that will be passed across async point and thread points, and debug just for us. And now we're going to have the constructor. The design pattern here is that the context, when it's created, cannot be muted, at least the user ID. Later, you might add some mutable cache, especially for access control. But for now, for this video, we're just going to have the user ID, but this pattern can scale relatively well. And so for our constructor, we're just going to do a new, and it's just going to take the ID, and it will return the context with the user ID. And then we're going to implement our property assessors. And for now, we're just going to have one that will return the user ID. So this way, we make sure that nobody can change the user ID of a context that is not within this module. Now that we have that, we can go back to our middleware authentication, and that is where we're going to implement the extractor. And we're going to create a code section for CTX extractor. So an Axum extractor has one requirement, and that is an async trait, which means that in Rust right now is not supported by default. And so we need to bring our cargo to ML and import the async trait crate. That will allow us to implement a trait that has an async function. So the trait that we need to implement is from request parts, which come from the Axum extract submodule, and that will be for CTX. And that takes a generic for state, so S, and the S requires send and sync. So there's two types of extractor, one which is for the body, which is more restricted, and one which is from any other information but the body. So that is what we're doing right now. And in another video, we can show how we can do body extractors. But this extractor will take information from the headers or the URL param and so on, which is what we want because we want to take it from the cookies, so from the headers. So now this trait has an associated type, which is rejection, and that we can give our error here. Now we're going to make that async trait because the method that we need to implement is going to be an async from request parts, and the signature is a reference of mute of parts from the request HTTP. And then the second argument is a state, which we are not going to use, and that will return a result which needs to match the error that we give in a rejection of self. Now we need to make sure to import the async trait, macro, and the CTX. Okay, so now let's implement that. We're going to do our debug print, and then we're going to have to extract the cookies from the parts. And the way that we're going to do that is we're going to have cookies, and in an extractor, you can do parts extract to give the type you want to extract, which is cookies, and that will be an await unwrap for now. Now the extract comes from the request part ext, so we make sure that we import that. And now that we have the cookies, so the same thing that we had the cookie in the middleware, we can paste the same code that we had before. And now the only thing that we need to return, then eventually, obviously, you want to do the token component validation, so that didn't go away. And then we're going to return OK, CTX new, and the user IDs that we just passed. And that's it. We did the extractor for CTX. And so now the cool things about that is we can go into our middleware require auth, and rather to have our cookies here, we just can have our CTX. And here's the trick. We can have result of CTX. There's many ways that we can inject an extractor. We can do the result, the option, and directly the CTX. And we're going to see all of this option later. And now that we had that, we can remove all of this code because that was part of the extractor. And now we just do a CTX question mark. And so that will give us exactly the same behavior as before, but now the CTX has been extracted with an extractor, which means that now we can use this extractor in all of the routes. So now if we bring our quick dev and our backend terminal, and we press save, we can see that everything works as before. So that's pretty good. Now, if in our quick dev, we're going to comment our login, and we are pressing save, now we see that on the server side, we are getting the error auth failed, no Auth-Token cookie, which come from our require auth middleware. So now to really understand how the extractor works, we can go to our require auth middleware, and what happens if we just put CTX. Here we're going to comment this out, because that doesn't make sense anymore. Now if we press save on the server, and save on the quick dev, now we're saying that the require auth middleware doesn't get called anymore. So we still have the error, but it comes from our CTX extractor. So in a way, if you require CTX in your handlers, then it will make sure that if you don't do result of CTX or option of CTX, then it will throw an error if it cannot get it. So that almost accomplishes the same result. Now, if we were going to, in our code here, if result to put CTX, now we put option of CTX and press save on the server and in our quick dev. Now everything works because it was an option, it was just none, but nobody said to fail on none, so everything was fine. So that gives you a lot of power. So in fact, here, if we were going to add a debug on CTX and press save on the server and the quick dev, we'll have our none over there. So for now, what we're going to go back result of CTX and our CTX question mark. And now we're going to enable that to make sure that everything works fine. Okay, so now we're ready to use our context extractor. So if we go back to our RAS tickets, now what we can do is after our states, we're going to have our CTX, and that is going to be our CTX type. And now I can add it to my create tickets, which obviously is going to have a compile error, but we're going to fix that next. And in fact, the way that I like it early is to add it also to all of the model CRUD APIs. Because again, eventually I'm going to use this CTX for privileges and access control as well at the model layer and not only at the web layer. So we're not going to use it right now. We're not going to implement the access control, but that is to have the pattern right from the start. So now we're going to go to our model controller. In our ticket now, we're going to add CID, which is U64, and that would be the creator user ID. So that is one of the conventions I have, but obviously you can name it the way you want. And then we're going to go to our model controller CRUD implementations, and we're going to add our CTX. And now we can have our CID from CTX user ID, and then we're going to add underscore CTX in all of the model controller methods. And now if we go back to our RAS tickets, everything compiles nicely. And one advantage of that now is that even if we forget the require auth, this route require to have CTX, and even the model require to have CTX. So we cannot really forget to pass it because otherwise it wouldn't just compile. Okay, so now if we bring our quick dev back and our quick dev terminal, press save, we see that now we have our CID equal 1. And if we press save again, because it's the same user, they both have CID equal 1, but the ID has been increased, obviously. Now, if we bring back our server terminal, we're going to see that our extractors has been called twice for each request. First, for the require auth, and the second time for the create ticket. And it's similar for the other request. So if we look at our code and we go back to our middleware auth and go to our from request part, that we're going to do all of that for each request twice. And in fact, the token component validation is going to be quite expensive because you probably need to connect to the database or some sort of cache and do the hashing again and all these kind of things. So we want to optimize that. And in fact, the cookie middleware that we added does this type of optimization. And the way it works is you create a middleware, and we're going to call it our CTX resolver. Your middleware can use other extractors. So it's going to have the cookies, and that will use our cookies extractor. And then one thing that we're not going to use, but just to show by example here, eventually you will also want to access the model controller, which will be your database connection in a way. So now in the body, we're going to have our debug print, and then we're going to get our cookies exactly the same way as before. And then we're going to compute our result CTX. And it differs a little bit. We're going to do it with match, and it's going to be very similar of what we did before with the OKR and the and then parse token. Then we have our OKArm, where we will create the CTX if everything is okay. And that is where we will have our expensive token component validation. And the reason why I did with a match here is that usually you will need to have async, and it works better like this than just having closure and map and then. So that is one way to prep the code for later. But obviously do what works for you. And then after we are returning our error over here. So now that we have our result CTX, we do not want to fail in this function, but what we want to do is to clean up the cookie if there is a result CTX error and it does not match the no Auth-Token cookie. Because if there is no cookie, then we don't need to worry about it. But if there is one and it failed, then we need to make sure that we clean it for the client. So when we have that, we're just going to say cookie remove, and we give the name of the cookie. We're going to import from tower cookies. So we're going to close this to make some room. And now what we're going to do is store the CTX result into the request extension. And so that is a trick here. So to do that, we do our request, extension mute. And that basically is an extension on request. It's like a data store by type. So we're going to do insert, and we can give our result CTX. So it has to be unique by type, otherwise it will replace whatever we have put before. And now that we have that, we can simplify our extractor. So we go down for our CTX extractor, and we don't need this code anymore because that completed once. And we still need to return the result of CTX. And so what we're going to do is get the extension. We're going to get the data from parts. And so the way that I like to do it when there's quite a bit of chaining is to put it in a temporary variable for now. Let's call it D. Doesn't matter. We're going to remove it later. And then we're going to do parts.extension. And then I can toggle the inlays like that. And now that we have extensions, we're going to do the get by type. So we're going to use the turbofish, the result of CTX. So that is a concrete type of what we want to get back. And that will return an option of result of CTX, an error. So now because it returned an option, we want to turn it into a result, such as if it doesn't have the result context in the extension, it will return a new error. And then our error will be something like Auth failed CTX not in request extension. And we're going to bring our error module, and we're going to add this error. So now that we have that, that will return a result of a reference of result. So we're going to do the question mark here. And so it's fine to fail on the extractor. If we don't have it, we have to fail. And then we are going to clone it. And in fact, we have an error because if we bring our error type, so that has to be cloned so that we can return the result. And now that we have that, we press save, everything compiles. So obviously we don't need the D anymore, so we're going to remove it. Now that we have done that, what we want is go back to our main.rs, and we're going to add this middleware just after the cookie manager layer. Because since we are going to need the cookie extractor, which is provided by the cookie manager layer, it has to be above it. So we're going to do layer, and then it's going to be a middleware, and now it's going to be from fn. But because we have the state that we're not using, but just to show by example, we're going to say with state. So that is a function that now we're going to give our state. So we're going to call the clone here, and then our middleware, our CTX resolver. Now if we press save and bring our backend terminal, that will restart the server, and then we press save on the quick dev. And now we have the request as before, everything is working very nicely. We still have our two extractor. So that is always the case when every time you call an extractor is going to be called and generated. But now the heavy lifting is only done once and everything else is just a lightweight clone. And then for the API login, even if we didn't need our CTX because we put it at the routes all, then everybody has a CTX resolver. So that's why it's important to not fail, but to make sure to capture the errors such as other middlewares or handlers can handle the case they want. Okay, so now that is quite a bit on the extractor and the middleware. And now we are ready to beef up our error. Now there's two more credits that we're going to use, and that is going to be the strum macro which is going to have some utilities for enum to serialize them as string. And we're also going to use UID v4. So we want to have a server error and a client error. Add a little bit more information, but just what is needed. So for that, let's go to our error module, and we're going to create a new enum, which is going to be our client error. We're going to scroll down. We're just going to have few variants. The first one is login fail. The other one is no auth, and we're not going to give any more details. And then the third one is going to be invalid params. And then the last one will be kind of a fallback, which will be service error. And for our convention, which is the client side, they are all uppercase snake case, which is not the convention of a normal enum, but we want that into our API result. That is just a personal preference. But if that is what we want, we're going to add the allow no camel case types. And now we're going to derive debug just for us. And then we're going to use strum macros. And we're going to use a macro as ref str. So that will allow us to serialize the enum variant as a string. And that is what we're going to send back to the client. So if we go back up, we have the error, which is going to be our main error, the server error. And we have our client error. So we want to be able to go from one to the other. So now to go from our server error to our client error, we're going to have a custom implementation, which is going to be implementation on error, and is going to be a client status, which is going to be the HTTP status, and the client error. That will take a reference of self, and it will return a tuple of status code and client error. So that is just the API we came up with, but obviously you can have your own. But the point here is that these methods will know how to convert a server error to a client error and the status code. So now we're going to do a match. The first things we're going to have our fallback, such as if it's not covered, it will go to a status code of internal error and will send back our fallback service error. Then we're going to add the one for the model. And so in this case, for this type, we want to have a bad request and valid params. And then for our auth, we are going to group them, and we're just going to send a status code of forbidden, and the client error variant will be no auth. And then last, we're going to have our login fail, which is going to be a one-to-one mapping with our login fail. But eventually, on the server side, you might want to know why the login failed. And obviously, you do not want to send that back to the client, because otherwise you are sending information back to the hackers. And now one little thing here is sometime when we are going to code, the fallback might be redundant. So what I like to do is to allow the unreachable patterns, which is the fallback at the bottom, such as I have more flexibility. But there's a point to argue that you don't want that, such as you are strict about making sure that you are always exhaustive and you don't need a fallback, for example. Now, if we go back up, we don't need to have a full response. What we're going to do is create a placeholder Axum response. And then we're going to put the error into the placeholder. So here's how it works. We're going to have a let mute response, and we're just going to take the status code internal server error into response. So that will create a response object. And then it's important to make it mute, because what we're going to do is insert the error, our server error, into the response. So we're going to do a response, the extension mute, so same pattern that we had for the request. So that's why Axum is very powerful. And then you can do insert, and then we're going to do self. And again, it's an insert by type. And then we're going to return response. So that is just a placeholder, and the magic is going to happen in the map response middleware. And one thing that we're going to do as well is we're going to use this little macro from strum to be able to have the variant name as a string. So now, if we go back to our main.rs, we're going to close main. And if we go down to our main response mapper, this is where the magic is going to happen. So first, we're going to create a UUID, and that will be the UID to match our server and our client errors. And now we're going to get the eventual response error. So the way we're going to do that is we're going to let service error, which is our error, and it's going to be our response extensions. We don't need to be mute at this point. And we're going to say get turbofish error. So that is our error type. And now that returns an option of error. So we're going to have our client status and error here. And if we have a service error, we're going to call our client status and error. That will return the tuple of status code and client error. So we'll have an option of status code and client error. So now if we have a client error, we need to build a new response. And the way we're going to do it is error response. We're going to get our client status error. We're going to get it as ref because we're going to reuse it later for the server request logging. Then we're going to map it. We're going to destructure it as a status code and the client error. And now we can create our client body. So we're just going to have the error, the type, which will be our client error as ref. So that is what Strum is giving us. And then we're going to have, for example, our request UUID, which is going to be UID to string. We're going to do a debug print. And now that we have this new body, we can create the new response. And so we're going to take the status code. Here we need to dereference it because what we had above was a reference of status code because we did it as ref. And then we're going to have our JSON of our client error body. And then Axum for this tuple implement into response. So we can just do that. And that will give for our error response an option of response, which is what we wanted. Now, a little side note here. The reason why the deref work, so if you go to the status code here and you go into the code, you see that the status code is actually of type copy. So when we are going to deref it, it's going to actually copy it. And so then after it can take the ownership. But the status code is still available for later. Now that we have that, later we're going to build and log the server log line. But for now, we're just going to do a debug print, which is server log line, the UUID, and then just a debug of the service error. And now as a return, we're going to say return the error response if there is one, or we're going to do an unwrap or the response that was already planned. And so here we have our server line, which will print our server error. And if we open our map over there, and here we print our client body, is the one that we're sending back to the client. Okay, so now if we bring our QuickDev server terminal and you press save on your QuickDev, what we're going to see now is that we have the CTX resolver and all of the request flow, and we have our server log line with our UUID. For now, there's no errors. Now, if we were going to comment out the login, such as we don't execute the login, then if we press save again, we're going to see that now we have the client error body, which of type no auth in this case. We have a server line with a full error, and then we have the matching UUID in both cases. Obviously, we have the same thing for the next request. Let's activate our login, such as everything works nicely. So now we are ready for the last step, and that is to build and log our server log line. And the server log line, which is a request log line, is different from tracing. Tracing is when you put debug and info and warning or whatever inside your code, such as you can debug it. But a request log line is one log line per request with the error or with other information. And if you do that early, you can first just print it into the console log, such as you can debug locally very quickly. And then when you deploy it in the cloud, you can push that to CloudWatch, for example, on AWS, and then you can query that with some cloud native tools. So to do that, if we go back up, we're going to create a mode, which is log. So that will be for logging. And now if we go to log, we're going to insert a SERDE with, which is a pretty good extension of SERDE. And we're going to see why later. We're going to import our create error and result, the SERDE. And now we're going to build our request log line. And so what we want is to be as flat as possible. And that is relatively important because in CloudWatch or this kind of queries, the flatter it is, the simpler it is. And if you start having too much nested, it can get pretty hairy. It's going to have some error attributes. We're going to make an exception right now for error data, which is going to be a value of JSON. So then after, we're going to add our HTTP request attributes, the path and the method name for now. Then our user ID, and then finally, we're going to add our UUID and our timestamp. So our timestamp right now is just going to be the epoch time, but eventually you want to have it ISO 8601. We're going to serialize it because the goal of that is to serialize into a new line JSON. It will give us a lot of flexibility later. And then we're going to use the skip serializing none, such as all of the option doesn't get serialized. So at least we use the power of JSON, just that we don't create too much noise when we don't have an error, for example. we don't have to serialize the error properties. So now let's close that. Let's make some room. And we're going to implement our log request function. And the goal here is that in our response mapper, we're going to call this function. And here we're like getting all the information we need to be able to build our request log line. So first we're going to have the UID, which is the UID for the request method and the URI. And then we have our CTX and the service error and the client error. The client error, we can consume it. And actually the service error, we can also probably consume it. But right now we're just going to take a reference. And then it just return a result of void because we don't need any data back. And now we're going to do a quick hack right now for the timestamp. It's just going to be a system now with a Unix epoch. Production, you probably want a UTC ISO 8601. And then we're going to have our error type, which we're going to map from the service error. That will return an option. And then we're going to have our error data, which will do a to value. And that also will be an option. And then one thing that we didn't do is our error needs to implement serialize, because now we're going to serialize to JSON. So we can bring our error and just add serialize. And now another trick here, when we're going to serialize the enum, so we're going to split the tag, which is going to be the name type in our JSON, and that will be the string of the variant name. And then we're going to have the content, which we're going to name data, and that will have the data of each variant when there is some. So now that we have done that, everything compiles, and we're going to create our request log line with our UID, our timestamp, our request information, our user ID from the CTX if there is one, and we're going to duplicate the client error type. So this way we can do some matching if we want, to do some search without having to look at what the client has. And then we're going to have our service error type and our service error data. And now that we have that, we're just going to print it right now as a JSON line. But eventually, you want to send that to a CloudWatch type of service. So now that we have that, we need to make sure that we get all of this information into our map response. So for that, we're going to go back to our main. And in our main response mapper, now we need to make sure that we are capturing all of this information. And that is, again, the power of Axum with the extractors, because we can just get the extractors from all of this information. So for our CTX, our URI, and our methods. And now we're ready to build our request log line. We're going to extract our client error. So that will give us an option of client error. And then after we can call our log request with all of the data that we have. And then, by the way, here's a little trick of unzip. It's pretty neat. It allows us to get the option of client error from the option of the tuple that we had above. So for example, if we go back to the source, that will be an option of status code and client error, but we just need the option of client error. So what we're going to do is unzip, which now we have a tuple of option of each. So they will be both some or both none, obviously. But then we only want the second one. So we're going to do a .1, and that will give us the option of client error. And that is what we need over there. So that is another cool little thing from option. And so now we bring our quick dev, our backend terminal, we press save, and now everything works fine. And we have our request log lines, one per request. And now if we deactivate our login, then we're going to have our client error and our log request with our client error type and our server error type with all of the data. And then we have our matching UID between the server and the client. And that, when you do a production application, this is gold. And that will be it for today. If you are still here, congratulations. You went from beginner to advanced in Axum, which is really an awesome web framework. It's not too high, not too low, very well componentized, and very complete. Until next one, happy coding.